Hello guys, so continuing from the first video. So as you can see on the right, like I have installed this Gorilla Mux package. So this is a popular Golang package for building WebSockets. You can read more about um, Gorilla WebSocket package in their official documentation. So yeah, we will be needing that to establish WebSocket connection between our hub to the Wails server and all the agents to the hub. Cool. And let's go through Wails code once. So if you open up your Wails code, so you will see this main.go. So now this main.go is the entry point for your Wails application. Now you have this main function where you are creating this app and you are attaching some attributes to the app. Okay, now if you see like background color, bind, height, width, all those things are attributes of of that GUI that you are seeing. Okay, if I runs the Whale server, um, yeah, sorry, cool. So if you see this thing, Whales dev. So yeah, so all the initial height and width we are setting this here, and if you see the GUI title here, we are setting all this. So all these attributes we are setting here along with background color. Okay, now in every application, like at the end of the day, this is a server. Okay, so in servers we have this concept of lifetime. Okay, so generally when you start up your server, let's say this is some t chart. Okay, and during some t uh, t naught time you started your server. Let it be some express server or some fast API servers like that. Okay, then from this initialization till it's shuts off. Okay, we are calling it as our runtime of our server. Okay, so all your business logic that you have written in your code, those gets executed during this time. Okay, now if you see, there is a time before even launching the app. Okay, those and what all events we will be carrying, we will be referring to them as startup events. Okay, think about having a database in your server. Okay, so whenever you are creating a database for your server, it's a generally good practice to create the connection object before launching the server. Okay, we usually follow a singleton pattern where we cache the connection object and use the connection object in rest of the runtime of our server. Okay, now yeah, so that's a startup event. And just like startup event, we also have this shutdown events. So here we generally write some code to gracefully shut down our server. Let's say deletion of all the third party connections that we have in the app. Okay, and if we are using, or if we are like writing some files to some local directory within the server, then that should not halt because of the server shutdown. It should be gracefully, like the complete file should be written, and then only the server should like shuts off. Okay, so all those logic we generally categorize them as shutdown events. So yeah, this is a general lifetime of any server. So on that, so you can see like in our app attribute we are putting this on startup, this app startup method. Okay, now we will see like what is happening in startup, but yeah, before that I want to show you this line, this embed line. So if you see, like we are embedding the frontend slash dist directory. Okay, So this front end directory will contain all your React code. Okay, we will be writing for our components. Now this dist so generally when you create a React app, we don't see this distribution directory unless we run React run build. Okay, then only all our components, all our pages, router, whatever we have written, those get compiled to a single file, into a single index.html file, and that file is only uh, rendered in our production. Okay, so yeah, this dist file contains the single HTML file where that uh, gets rendered. Okay, and this is the directory which gets embedded into the Wails application, and all our Go logics that we will be building, those will be pointing to this directory. Cool. And yeah, now Go has this feature, like once you embed something, so once you embed your front end files to your server, okay, now your server can take control of handling all the logics that you are carrying out in your front end. For example, uh, let's say I want to embed a function, okay, that I have written in Golang. Okay, I can use that function in my React. So I'll show you. So for example, so yeah, you can see here I have this app. I have this GUI open, and it is asking for my name. Okay, if I give my name, so when I click on this button, then yeah, this text gets changed. So this is must be like taken up by some function, this input, then the function must be returning some new string which gets rendered over here. Now I can show you that function. So if I go to app.go, so this is where our app struct is defined. So you can see like our app is containing a context. Okay, now this is a global context for our whole Wails application. So whatever will be happening inside our Wails application, this context will carry that information. Okay, or like you can think of like whatever function writings and all, any calls will be making, those will be taking this context um, first and then running them. Cool. And yeah, see now this greet function, if you see the return format, you can see it's taking this hello, like it's taking the name, okay, and simply replacing this ampersand s here. Okay, and this formatted text is what we are seeing here. Okay, now this function is written in Go. Okay, now in order to render this return output here, so it should be present in our JS directory, right, or our React directory. So if I search for greet, yeah, you can see in app.tsx it's there. Okay, now this function is same as what we are seeing in our app.go. To this side, yeah. So this Golang function is being used in our TypeScript file. So yeah, so that's the power of embedding. So we can write any function or any utility, not objects, like variables that we want to use in our front end. So yeah, we can do that by embedding. So yeah, more on this you can read in Wails documentation, so how they are using this feature, and yeah, how they are rendering. But yeah, let's get started on our implementation. So in our last video we created this internal, okay, and we created this file constants and hub. Here I have created another directory because I am creating this hub package. Okay, so I just created a directory inside my internal. Now if I show you my internal, so this is the internal. There I have this hub package, and inside that I have this constants and hub.go. Okay, earlier they were like inside internal. Okay, so let's complete our hub and constants. Cool. Now inside a hub, uh, we'll be implementing some methods, okay, that our hub can use in order to connect our clients. So let's first um, see how this hub will work. Okay, so generally in a hub kind of a architecture, okay, you have multiple clients. Okay, so it's like a spider, only in the central you have the controller. Okay, we call it hub, and all these clients are connected to this hub. Now here, uh, so if you have used like Siri kind of application, like this um, Apple Siri, and if you have connected it to some other devices, let it be your speaker or something, so generally those thing uh, gets connected over your local network. Okay, you can think of your Wi-Fi. Okay, and whenever a new device joins the hub, okay, that event gets transmitted to all the connected clients. Okay, so that they can also communicate with this guy. Okay, cool. So similar setup will be having here. Okay, and why will be needing it? So it's a good thing. Let's say I am setting up my devices in some corners of my room, and whenever I'm attaching a new device, I can later build on some other functionalities, like some kind of acknowledgement for all the devices, okay, that are receiving this event notification, some new devices connected. And from that also I can do some like ping pong kind of a setup, like okay, I have sent this message to this guy, like someone has connected, but I haven't got any acknowledgement from this device, which basically means that device is like shut down or the browser is closed, something like that. Okay, so for in order to do that, we'll be creating some endpoints. So that will be first a manifest um, endpoint. Now this manifest endpoint will carry the device information, okay, that we can get. Okay, if we simply give the device ID, that should give me the device IP address, the last time we have received a frame from that. Okay, and some other details we can also put in manifest. Cool. Then we will be having one ingest URL. Okay, now this endpoint is the main interface for our agents. Okay, here we will be um, creating our WebSocket connection between our clients, and we will be receiving those frames. Okay, and building packets over them. Okay, and storing them in some objects, so that later our Wails server can consume those packets and display it in its own component. Okay, so ingest will be for that. Okay, then we will have some viewer, or you can say some view endpoint. So this is the endpoint that our Wails server will be using to collect the frames and rendering it there. Okay, so you can think of this, all this calls will be handled by slash ingest. Okay, and all Wails to hub calls will be handled by our view. Okay, now manifest is something we can use in our desktop app to get like all the device information. Then yeah, and finally we'll be needing a endpoint to initialize our agent. Okay, we can call it like slash camera. Okay, so yeah, there's manifest ingest camera, view camera. Now this endpoint will be returning a HTML component. Okay, that these clients can use. Okay, and whenever they are in our HTML file, or like in our HTML page, we can inject the, like we can initialize our ingest endpoint inside this HTML, okay, so that those client will be automatically connected to our hub. Okay, I think you guys will have more clarity once we code it. Now, yeah, one more, like a standard endpoint we will be having, which is health check endpoint for our server. Cool. So let's create our hub. Okay, so let's create a hub struct. Okay, nope, not C++. So what all information we will be carrying in our hub? So what all things we will need? So we have views, we have ingest, so we have clients. So we will be using uh, some kind of a tables in order to store like device ID to the corresponding WebSocket connection, um, like the person who is like viewing the screen in the Wails, uh, and there we need view to a device to WebSocket connection. So yeah, um, first of all, we will be using, let's say we call it viewers. Okay, now this viewer will be a string, will be a map of string. Okay, this is like the device ID, and then to device ID to another, we can say WebSocket uh, connection to bull. This we are doing. So it's like the device ID to their corresponding WebSocket connection, and this bull is for whether that WebSocket connection is alive or not. Okay, so these are my viewers. Then there is this ingest, uh, ingest we will be needing, and here we will simply store device to the corresponding WebSocket connection. Cool. Now this will be used for our Wails application. This will be used for our hub to agent. Then last thing we will be needing is a list of all the devices connected, and there we can store their manifest directly. So it's a yeah, this will be again device to their corresponding manifest file. So let's call it type, let's call it stream meta. Cool. And yeah, and one more thing we'll be needing is, so we are doing all this WebSocket connection, we are receiving frames from the client, then we are also putting some kind of acknowledgement message to that, okay, and handling another WebSocket connection to the Wails. So overall we will be needing a lock over all this concurrent uh, activities, okay, so that two like two things won't be happening in the same WebSocket connection. Okay, otherwise our Go server will basically panics out. Okay, because all, so if you think in this single connection, uh, like in this single hub, okay, this picture is more nice. Yeah, we are receiving here, we are sending the packets to the Wails server, and we are receiving here concurrently, and at the same time we have to send it here. Okay, so that should be a overall locking mechanism over the hub, so that once you received it, put a lock over there, and then first send it, unlock it, then again collect it, then send it, and do that. So if we do that, then all those go routines that we will be creating, those will be in sync, and yeah, the server won't be panicking out. So we can create a mutex here, okay, and we will be reading as well as writing, so we can say rw mutex. Okay, now other thing we'll be needing is, so how Gorilla WebSocket works is, so it converts your HTTP connection into a WebSocket connection. Okay, so it uses this upgrader method. So this updated method takes your HTTP response writer and your HTTP request objects, and then it converts them to WebSocket, like your Gorilla WebSocket writer and request object. So yeah, so we can say WebSocket upgrader. Cool. This upgrader is not there. Let me check. Golang. Oh yeah, we are not using this. So GitHub. Cool. I think I need to add this in Go mod. I can add this here. This indirect. Oh, I know how to do it. Let it be there, and here it should be upgrader. Cool. If I simply do a go mod tidy, this should get resolved. Yeah, cool, nice. Yeah, why to do it myself? Cool. So we have upgrader, this. Now let's complete our stream metadata. So what all things we need? So we need a device ID, and yeah. So we will be marshalling it into JSON like this. Then what else? So now, yeah. So when we are running an agent that is accessing our camera or maybe our voice profile, like all that information cannot be carried out over simple HTTP calls. Okay, if you are doing a local host call, then it is possible, but when you are using your hub, okay, and you are reaching out to other devices, okay, that has different IP addresses, so those things won't be happening using your normal HTTP calls. Okay, they require you to set up a SSL certificate. Okay, and after that only you can access your camera. Okay, so yeah. And once you do that, so then only you can access your camera, send out frames, and do all that crazy stuff. So yeah, uh, and later in the videos I will show you like how you can use OpenSSL, and you can create a self-signed certificate that you can use and load it into your hub. Okay, so that these devices will recognize your hub as a proper IP address, and yeah, you can open up your cameras in your devices and send out the frames. Cool. Now yeah, when you do this, uh, there are some default settings where you can say like the width and height of the frames that I'm delivering, it should be this much. Okay, so those information we can store. So width, so we can say like this device is sending this much width and height frames. Okay, and yeah, it won't be a string, it will be an int. Height. So yeah, then other thing we will be needing, yeah, so we will be setting up this cameras in different rooms. Okay, right now I wanted to set it to in a single room, but let's say we expand it to some bigger project. Okay, a full surveillance in-house setup. Okay, so we can set it up in different rooms and connect them all over the same Wi-Fi and get all the frames. So we can take a room string also, like where this device is currently, and let's marshal it as a room. Cool. So we have device ID, width, height, room. Then yeah, so we will be sending out, and let's say we lost connection, then we will be needing some last seen timestamp. Okay, so we can collect a uh, um, we should marshal it down to some last seen, and it may happen not all devices can send that information, so we can leave it as empty. Okay, it can be null, that's fine. And in every streaming we need this information, which is fps. Let's keep it like this. It will be, yeah, so this is a int object, and will be marshalling into fps. Cool. Yeah, only this guy is empty, and rest everything should be there. Cool. Now let's create a constructor for our hub. So we can say it takes new hub, and it returns a pointer to the hub. Okay, cool. And we can return here. Cool. So here in upgrader, I can say WebSocket dot upgrader. So here we need to mention some things. So when we are converting our HTTP network call into a WebSocket connection, it's always better to have some read buffers and write buffers. Why we need it? Because if you think about the data that you are sending, okay, let's say there are two clients, or let's say this is the guy. Okay, so let's say I want to send a text. In our case this will be a video frame, but let's take the example of a text. So let's say txt. Okay, let's say this client has this text, and this text has to be sent to the hub. Okay, so if we do it character level sending, okay, or character level transportation, then it it might overclock our CPU, and we will be making so many network packets that we won't need. Okay, so generally whatever data we want to send, those gets wrapped around over some kind of a metadata layer that contains like source, destination address, and other some other information. So you can simply see like let's say when I'm doing this, any network call, is it capturing? It's not capturing, but yeah, cool. So all this information are there over the data packet. Okay, so like cross origin, content encoding, date, server, vary, all this information are there. So all those details are filled here, and then only this data packets gets delivered to our hub. So just think, if we do that for every character, okay, we'll be generating a lot of metadata. Okay, and yeah, and too many sends we will be doing, and the server also has to acknowledge it, right? So too many acknowledgement will be happening. So here you can see like we have four. So four like sends uh, to the hub, and four receives acknowledgement to the client from the hub. So yeah, so that's a very tedious, and it's very complex, and we will be like using a lot of resources for a simple task. So it's better to uh, divide this whole data into segments. Okay, now use these segments, like put these segments in one go inside one data packet. Okay, so you can think like, if I tokenize this text into two tokens, okay, let's say in one data packet I'm sending te, and in another I'm doing xt, then uh, then using only two network packets I can deliver the whole text to my hub. So yeah, so in order to do that, your WebSocket upgrader, it asks for to put some read buffer size. Okay, So when it is receiving something, what should be the buffer size it can handle? So this buffer is like, when you are sending this token, this guy will also be collecting the segments in some buffers, okay, and then it will be like collating all these buffers into the final data which we will be using. Okay, so in order to divide those receiving into buffers, so we need to mention some size, so we can keep it to 1 KB, and it will be better to create some constant, so we can say max read buffer size, and let's keep it to 1 KB. And similar to read, we should do for some writes, write buffer size. Okay, cool. So let's use them here. Max read buffer size, write buffer size, max write buffer size. Cool. And yeah, also, so yeah, uh, when you are like doing all your dev steps in your local uh, environment, you are fine. Okay, you are creating servers there, you are creating front end application there, so your front end can communicate to your server can communicate to your front end, so there is no issue. But when you like put your front end and your back end into separate network interfaces, then there is this uh, uh, the, both becomes from different origins. Okay, so as long as your front end and your back end is in the same system, okay, they will be having a same origin, which is your system itself. Okay, but when you are putting them into different let's say network interfaces, okay, this guy has its own IP address, this guy has its own IP address, then they become cross origin. Okay, you will be like delivering network packets between two different IP addresses. So yeah, so in order to like accept the communication between these two, we need to set up a CORS policy. So in the Gorilla, you can set something like a check origin attribute, and you can pass a function like whatever request I am getting. Okay, don't check for anything. Okay, simply say that I am trusting it. Okay, so we can we can import the net HTTP. Yeah, cool. So yeah, so this is a kind of a control we can keep in our server end, like whenever we are receiving request from some unknown entity, okay, we can put up some logic here to filter out only those which we trust. Okay, but right now I will be using my like my room, my devices, so all like I know their origins, so I will trust all of them, so I'm just putting that true here. Then now your Gorilla this WebSocket upgrader, it also to deliver fast, sometimes they compress the data. Okay, but now we don't need compression, because once we compress our frames, then there might be data losses happening. Okay, so let's just keep this enable compression flag to false, so that we will get the actual data without any loss. And yeah, uh, the last thing we'll be needing a handshake timeout, like when two things are like creating a TCP connection in between them. What's the maximum time we can wait until both agrees like they want the TCP connection to be established? So we can keep it to some 10 seconds or something, let's say 10 second. Cool. So up to here upgrader is done. Now let's create our viewers. So viewers is a map string, it's a map of a pointer to a WebSocket connection. Let return create this. Then ingest is a map of string with the WebSocket connection, comma. Cool. And this meta is a map for each device to their stream metadata, which is their manifest. That's the pointer. Cool. So up to here we have created our ingest. Okay. Now by default this will be initialized, so we don't need to like explicitly define it. Cool. Now let's start off with a simple let's start with a simple endpoint. Let's build our health check endpoint. So let's say hub object, and let's call it health check. And what does it do? It takes the HTTP response writer and the HTTP request pointer. Okay, it doesn't and it simply writes to us that the server is alive. Capital. Cool. And let's bind it to some endpoint. Okay, so hub, and let's do it like start server. Okay, so it takes a context, and there goes context, there goes context, error. Okay, so where we will be using it, if I do context, yeah, so where we will be using it, like, so in our main.go file in our Wails server, if you see, so we can put some startup events here, right? So we will be creating we will be launching our hub server inside this startup, okay, with some other port number, okay, so that our Wails server will be running in its own port and our hub will be running in a different port, okay, and whenever our Wails starts, our hub servers should start. Okay, cool. So it returns something, and let's create a mux http new server mux. Once we have created this, then we can bind our function to some endpoint. Let's call it health check. So whenever someone hits our IP address, colon port / health check, so this hub dot health check should run. Cool. And let's capitalize it. Also, if we are doing a / request also, it should run our health check. Cool. So other functionalities we'll be needing is there is health check, then there is handle ingest. So that request. Then there will be one handle view, and then there will be one handle manifest. Cool. And once we have this, we can create the endpoints, view, ingest, views, manifest, and yeah, we will be needing that camera endpoint, but for that we will be creating a static file inside our hub. So I can do make dir internal hub static. Okay, and I can create a HTML file inside that. Index.html. I think, yeah, where's the met? Cool. Camera. Cool. You can do this. Cool. So yeah, here we can say handle, simply handle, and before that we need to embed this HTML. Let's rename it to Rename it to, let's say, camera.html. Cool. So here we can embed our uh, file first. So I will say I need embed, and I want to embed the static camera.html that is present, and I can create a static file server embed file. Now here, since we want this camera HTML page to be active when our hub is active, because this camera HTML is the point where they can connect to our hub, like all our devices. Okay, so we will be creating a handle func for our camera, and here we will be doing writing up anonymous function response writer that takes the request http request, and what it does, it simply serves the file. So this is the one. Cool. Writer request and static fs and location to our file system, to our camera page. Cool. Now let's change this. So health check is done. Now this should be ingest, this should be handle ingest, and this should be view, and this is handle views. Okay, now this guy will be manifest, and this guy will be handle manifest. Cool. I have to return something. Cool. Then so the setup is something like, when Wails server start, our hub is starting. Okay, so when our Wails server, I'm shutting it down, so you can see, like, when I'm doing Control C, it shuts off, right? So our server should also shuts down at the same time. Okay, so we can create a go routine, okay, that will be listening to the context. Okay, so this is our Wails context. Okay, so it will listen to the Wails context. Okay, and if we receive something from this done channel, okay, then we can shut down our this hub server. Okay, so what I remember is http shutdown should be there. It's not there. Let me just check. Shutdown server using mux. Okay, yeah. I haven't created, so I have only created the mux. Okay, I haven't created the server itself. So I can say server colon the HTTP package, and we need to create a server. So server, and here I can say address. I will bind to all my interfaces, and I will say port number is 6699, and the endpoint handler is the mux that I have created. And yeah, now I can use this server is shutdown attribute, and just use this context for shutting down. And yeah, this go routine will be spawned, and address handler here. Handler. Cool. So this coroutine will be running in the background, and in the end I need to start the server. So server dot listen and serve. Cool. Okay. Yeah. Cool. Now let's put this server initialization to our startup event. Okay. So let's create this app with let's modify this with hub object, and why it is not able to import this, should be automatically doable. Not initializing. So let me check using cam field. So internal hub. Okay, that should resolve my hub. Cool. Yeah. Now when I'm creating this app, I can create a hub inside it. So h will be hub dot new, and yeah, it always gives the pointer, so it will have the pointer. Now inside our startup I can create a go func. So since both will be, so this will be starting off this hub server, so that should run in a different thread, so I can run it in a different go routine. So if I'm getting some error from app.hub.start server, and let's give the context of the server, and if error is not equal to nil, I can say log fatal f something went wrong while running hub. Error. Cool. Now this shuts off the Wails application also, and yeah, I need to call this. Cool. Let's test it out. Okay, this guy is there. Now if our hub is running, if I do a localhost call to the health check endpoint, it should work. Cool. So our Wails server is up, as well as our hub is up. Okay, because I'm able to get the health check. Cool. So this is all for this video. So in later videos we will be covering on the implementation of ingest. Okay. So yeah, just stay tuned to watch this video series, and if you learn something new, please do like and subscribe. It will motivate me to make more videos. So yeah, thank you.